Hi everyone. It's good to see you again. So welcome to the online class. So today we are going to see about I/O ports. So input and output ports. Now I am sure you know this is your microcontroller. So what is a microcontroller? So microcontroller consists of microprocessor along with some peripherals. So what are those peripherals? RAM, ROM, serial port, timers, IO ports, etc. But here in your 8051 microcontroller, these are nothing but your peripherals. Okay. In some other advanced microcontrollers, you can find as many more peripherals. Okay, additionally. But here in your 8051 microcontroller, only timers, serial port, RAM and ROM, and IO ports are nothing but your peripherals. Now today we are going to see about IO ports. So you know that 8051 microcontroller consists of 4 IO ports. So what are the names of these 4 IO ports? Port 0, port 1, port 2, and port 3, right? And all these ports are nothing but bidirectional. What is meant by bidirectional? That means it can act as an input port or output port. Okay. And what is the size of the port? 8 bit. So what is meant by a port? It is a combination of pins. How many pins here? 8 pins. So that's why it is nothing but a 8-bit port. So we are having total 4 ports. That means we are having technically 32 pins to the input or output devices. And there is one advantage in this IO ports. What is that advantage is, apart from general purpose input and output operations, it can also perform some special functions. So that means alternate functions. Now if you observe, the port 0 can also act as multiplex address bus and data bus. So if you are paying attention to your last classes, and you know that address bus size is 16 bit. External address bus size of your 8051 microcontroller is 16 bit. That 16 bit is divided into two 8-bit addresses. Okay, one is A0 to A7, another one is A8 to A15. And the lower order address bus, that is your A0 to A7, is multiplexed with the data bus. So what is the size of the data bus? 8-bit, because it is a 8-bit microcontroller, right? So the data bus and lower order address bus is multiplexed together, and it is multiplexed with the port 0. That means the port 0 can also access multiplexed address bus and data bus as well as input and output port. Okay. Now coming to the port 1. So the port 1 is just a bidirectional port. That means either it can act as input port or output port. There is no alternate function for the port 1. Okay, remember this point. And coming to that port 2, the port 2 is also nothing but a bidirectional input output port, and also it can perform some other alternate function. So what is that alternate function? It can also access higher order address bus, that is your A8 to A15, right? Now coming to the port to 3. So if you look at the port to 3, the port 3 is also nothing but bidirectional input output port, and it is also having some alternate function. But here there are many alternate functions for your port 3. So what are these alternate functions here? The It consists of serial port pins, that is your TXD and RXD, and the next one, it consists of interrupt pins, INT0 and INT1 external interrupt pins, and there are timer inputs T0 and T1 for the two timers, and the last one is control signals. So these are the 8 different additional functionality the port 3 can able to perform, right? So this all, I think we have already discussed this during our pin diagram explanation of your 8051 microcontroller. Okay, now we are going to see the structure of each and every port. So what is exactly port means? So port is nothing but a combination of 8 pins. Combination of 8 pins is nothing but your port here, right? Now it can act as input and output, input or output port. Now first of all, you need to send some data to make the port acts as input or output. That means you need to set the direction of the port, whether I want my port to work as input port, or I want to work with my port as output port. So how you will set the direction? Direction means whether the port input acts as input or output. How you will set the direction? With the help of two digits. What is the digits? 1 and 0. Okay. Now, whenever if you write 0 to that particular port pin initially, remember this point. Whenever if you want to make particular pin of that particular port to act as output, you need to write 0 to it, right? And whenever if you want to make the particular pin of the particular port to as a input pin, you need to write 1. That means with the help of 1 and 0, I am setting the direction of the port, right? So whenever if I write 1, what will happen? The particular pin here, the particular pin, there are port means 8 pins. I'm talking about this particular pin. If I want to work, I want to make this pin as input, what I need to do? I will write 1 first initially. Okay, that means this pin acts as input pin. And what I need to do to make it as output port, output pin, I will write 0. Okay, when I will write 0, it will act as output. When I write 1, it acts as input. Okay, now with the help of input, what kind of input devices I can connect? You can connect sensors. Okay, you can connect push buttons. Okay, and there are many input devices like your keypad, keyboard, etc. Okay, these kind of input devices you can connect to the input pins of your particular port. And what is the output devices? What are the output devices you can connect? You can connect actuators like relay. So you know relay, right? It will control the large appliances current with the help of small current. That is your relay. And you can connect LEDs. Okay, and you can connect displays, 7-segment display. Yesterday we have seen 7-segment display in the addressing modes class. And we can connect LCD display also, and also we can connect motors, right? These are all nothing but your output devices. Okay, so these kind of output devices you can connect to the particular port, right? Now we will see what is the structure of each and every port. So we are having total 4 ports. Each and every port has one structure, and I am discussing the structure means about this particular part. So there is a particular each and every port has one pins, and each and every pin has one structure. Okay, the same structure is applied to all the remaining pins of that particular port. So if I take port 0, I am discussing the structure of one pin. The same structure will be occupied by the other pins also, right? Now we'll start with port 0. Okay, so this is the structure of your port 0. So by looking at this diagram, I'm sure you are worried about this, but I'm repeating this point again. So whenever if you want to try to learn this any topic or any diagram, you need to understand it first, right? So we'll make it port 0 structure we'll understand first, and later we can able to learn it easily, right? Now if you observe clearly, for this is nothing but the entire port structure is nothing but one pin. Okay, so each pin consists of this circuit. Okay, I'm having total 8 pins, right? So I'm taking only one pin. That's why I have taken port 0 point X. X means represent any pin. Okay, so this is a one pin structure. Now if you look at this, there is a latch, okay, and there is a mux multiplexer, right? And you can see there is a tri-state buffer. These are all called a tri-state buffer. I am sure you know the tri-state buffer means, right? And this is the NOT gate, AND gate, and there is transistors, right? Now you look at this latch. So this is called latch. So latch is nothing but 1-bit storage element. Now here we are using a D flip-flop. So D flip-flop acts as a latch, right? It can store 1 or 0. Now what is the operation of the D flip-flop? Whenever if you give the input, whenever the clock signal is applied, then only it can able to send the input to the output, right? The Q and Q bar. So Q bar will get the same input from the D, and Q bar will be able to get the inverted input from the D, right? Q consists of same input, Q bar consists of inverted input, right? Now what I told you, I want to make this port 0 as a input. I mean port 0 particular pin as a input pin. Okay, now we will see the input operation of this particular pin. So input operation. What is input operation? Whenever if I want to make particular pin as an input, I need to write 1. Okay, where I need to write 1? Here, internal pin. So this is your internal pin where we are able to sending the data, right? Now you look at this internal pin. where I want to write the value. What is the value I need to write for to make it as an input? 1. Okay, write 1 there. Okay, whenever if I write 1, the same input has to be get into your q, right? Q and q bar. Whenever if you apply the clock signal to your D flip flop, that means write to latch. This is one signal. Okay, whenever if you apply a clock pulse, whenever if you give a signal, okay, whenever if you give 1 to it, we can able to get the input to the q. Okay, now what is the value I will get here? 1. Okay, what is the value I will get here? 0. Okay, whenever this is 0, now you can able to get the same 0 over here. Okay, and you can observe there is some address or data and control. Okay, so this control signal will able to control this multiplexer. That means whenever if you want to make it as a address or data bus, I'm sure you know that port 0 can also perform as a multiplexer, address bus or data bus, right? So in order to make it as a address bus or data bus, the control signal will be applied. So if you don't want to make it as address bus or a data bus, and I want to make it as a general purpose input and output port, the control signal will be 0, right? Okay, now whenever you will get the 0, the switch will be here. Okay, this is a mux. It can able to switch here or it can be able to switch here. Now we are not making the address bus or data bus. I am using input and output port. That's why the switch is connected to latch. Okay, now the 0 is applied here, you will get the 0. Whenever if you apply 0 to a transistor, what will happen to the transistor? It will be off. Okay, now what I mentioned, the control signal. So control signal will be 0. Why 0? Because I am not making this one as a address bus or data bus. Remember this. Okay, whenever the control signal is 0, whatever the value apart second value of your AND gate, obviously the output will be 0. Okay, whenever this is 0, what will happen to this transistor? Off. That means here transistor is off and this is transistor is off. What will happen at this particular point? This particular point will be in a floating state. Okay, whenever these two transistors are in off, this particular point is nothing but your floating state. So that floating state is also, we are calling it as true bidirectional state. So true bidirectional means whatever the value you will send here, I can able to read from here. Whatever the value, if I push from the this side, I can able to send the value to the outside. That is called true bidirectional state. When you will get the true bidirectional state? Whenever if you want to make these true transistors off. Okay, now so whenever it is a true bidirectional state, I am using the input operation. Input operation means I will read the value from the pin. Okay, now we will send 1 0 to it. Okay, 0 or 1. Okay, whenever if I send the 0 or 1, I can able to get this here. Now it will go, it won't go, the signal cannot go beyond this one. Why? Because this is tri-state buffer. So for tri-state buffer, if you are enabling that with the help of read pin, okay, that means I am reading the data from this pin. Okay, whenever this is 1, then only the signal can be allowed through this buffer. Okay, and that buffer value is given to the latch. Now the whatever the value you are sending here, that will be stored inside your latch. Earlier we are giving that 1, that 1 will be replaced with the 0 whenever if you are sending 0, right? So this is nothing but your latch, which can able to store 1 or 0 of your input signal. And still you can able to read from the latch with the help of one pin called read latch. That means it will read the value present in the latch with the help of this buffer. Whenever the read latch is 1, I can able to read this from their latch, or whenever if I want to read the pin, I can able to read from this pin with the help of this tri-state buffer. Understood this point? Okay, this is the input operation. Now coming to the output operation. What is meant by output operation? I want to send a value to this particular port, particular pin of this particular port. Okay, I am sending, I want to send 0 or 1. So if I send 0, suppose I have connected LED. If I send 0, LED will be turned off. When I send 1 here, LED will be turned on, right? So now I want to send 0 or 1. Now what I told you, whenever if you want to make this one as a output port, you need to send 0 first. Okay, you will send 0. What will happen? Whenever you are sending 0, you need to apply the write to latch signal, because the clock is needed for the D flip flop. Okay, whenever you are giving 0, the Q will get 0. What happens to the Q bar? You will get 1. Now the actually the control signal is 0. Why? Because I am not using the address or data bus. Whenever I am using the address or data, I need to make control signal 1. Now I am not using that one, so the control signal is 0. That means the switch is here. Okay, whenever if I am sending 1, the 1 will be sent here. whenever if I are receiving the transistor is receiving 1, that means the transistor will be in on state. Now what happens to the control signal? Control signal is 0, that means the output of this AND gate also 0. Whenever this is 0, that means your transistor is off. This is off, this is on. That means whatever this value, okay, is getting grounded. That means technically we are consisting 0. That means I am sending the 0 from this output port. I am writing the value 0 here. I am sending the value 0 here. See, something magic happened. I am sending 0, I am getting the output 0 because it is the transistor is on, because it is grounded. Whenever it is grounded, whatever the value present in the floating state, they can able to ground. That means technically I am having the 0 here. That means I am sending the data 0 there. Now what happens? I want to send the 1. Okay, we'll take the same operation. Okay, now I will write 1 here. I will apply the latch signal. So whenever the clock signal is 1, the D flip-flop will send the output to the Q, that is 1. And what happens to this Q bar? It becomes 0. Whenever this is 0, it becomes transistor off, right? And what happens to the control signal? I am using output operation. I am not using address and data operation. That's why the control signal is 0. So whenever this control signal is 0, what will happen? The output of your AND gate is also 0. And whenever this is 0, this is 0, what is happened? Both transistors are off. What is the both transistors are off? That means it is in true bidirectional state. Whenever I say true bidirectional state, that means whatever the value present here, whenever if I am sending the value to the output port, I will push from here. But what is the value present in this point? There is nothing, because it is in a floating state. Now for that purpose, we are using one external pull-up resistor. If you know the subjects of EDC, etc., you can know the concept of pull-up resistor. Okay, so with the help of pull-up resistor, I can able to send the one value to this one, because I want to send one here. When I am writing 1 here, I need to send the 1 here, right? So technically there is nothing value previously before connecting the external pull-up resistor, right? But still I want to send the 1. That's why I will add external pull-up resistor there, and I will send the value 1. Okay, that means there is a point to be noted here. Whenever if you want to perform any output operation, the must and should you need to connect the external pull-up resistor for the especially port 0. Understood this much? Why? Because if you don't connect the external pull-up resistor, you won't get the value from your outside of that particular pin. So that's why for every time whenever you are making the 8051 microcontroller port 0, only I'm telling about port 0. For the port 0, you need to connect external pull-up resistors for each and every pin. Why every pin? Because just now we have discussed the port structure of the only particular pin. For the particular pin, I have connected one resistor. Total how many pins are there? 0 to 7. That means I need to connect total 7 resistors, sorry, 8 resistors. And the majority of the time we will use the 10K resistor. Okay, because there is some advantage by connecting the resistors of 10K. Okay, you can connect more resistance also, but you will get some bad results. So that's why it is suggested to connect a 10K pull-up resistor for each and every port pin whenever you are using the port 0 as a output port. For no input port, that means for input operation you no need to connect, right? So that is about your port 0. And the port 0 can also access alternate function, that means multiplexer address bus and data bus. That means you need to generate two control signals, one for address and 0 for data, vice versa. Okay, so whenever if you are interfacing the external memory to your microcontroller, you will interface with the help of address bus and data bus, right? To differentiate between address and data, I need to generate two control signals. One is 1 and 0. Okay, how to generate 1 and 0? Okay, in this point of view, I am not writing any value here. Okay, forget about these flip-flops and mugs, and here I am using only control. So when I am telling you, whenever if you want to make address or data, okay, what is the value of the control? Has to be 1. Okay, and what happens to the data? Data also 1. Okay, now whenever the control is 1, that means this multiplexer can able to switch to connected to this particular pin. Okay, right? Now 1 will be get here. This is the NOT gate. You will get 0 here. What is the 0? Which will makes your transistor off. Okay, now address is 1. I mean the address or data bus is 1 and the control is 1. What is the value of the output of your AND gate? 1. 1 means this is on. That means I can able to send the 1 to your transistor and you can able to send that same one to your pin. Okay, that means I have generated one in this point of view, and still I can able to generate 0. How to generate 0? Just make address or data to 0. Okay, and control to 1. Whenever if you are making 0, what will happen to this one? Because you will get 1 here. 1 makes transistor, sorry, it has to be on, but I have written off. Actually the transistor will be on. So whenever the transistor is on, the actually whatever the value you will get here, it gets grounded. Whenever you will get grounded, whatever the value present is nothing but 0. So the same 0 can able to send here. So because of the 1 and 0, I will get the output for the AND gate is 0 and the transistor is off. That means I can able to send the 0 there. That means I have generated the 0 signal. Okay, why I need to send why I need to generate 1 and 0 for the alternate functions? Because I need to differentiate whether I am sending the data, whether I am receiving the data, whether I am making it as address bus. Okay, that's why to differentiate between data and address, we need to generate two control signals. That's why 1 and 0 is generated with the help of this control signal. Okay, so this is your port 0 alternate functions and input operation and output operation. That is the end of your port 0 structure. Okay, next you will see the port 1. So port 1 is just a simple bidirectional input and output port. That means it is don't have any alternate functions. That's why the diagram previously we can see that address and data and AND gate is not there because there is no alternate function. Okay, so this is the port 1 structure. It is just like your port 0, but here in previous port 0, we are using external pull-up resistor. That means whenever if you want to make port 0 as a output port, you must ensure to connect the external pull-up resistor. But here from the port 1, there are internal pull-up resistors for each and every port. That means port 1, port 2 and port 3 has internal pull-up resistor. That means manually we no need to connect any resistor. By default, the port pins consists of internal pull-up resistor. Understood this much? Okay. Now we will see the operation for the input operation of your port 1. So what is my input operation? Whenever if I write 1 here, then this makes as a input pin. Okay. Now we'll send 1 here. What happens to the write to latch? Write to latch signal is 1. Now whenever I'm sending the 1 from the D, you will get 1 here. And what happens to the Q bar? Q bar will get 0. Whenever this is 0, the 0 same 0 will be into here and you will get 0, which will makes your transistor off. Whenever the transistor is off, the internal pull-up resistor is connected to VCC and it is grounded, right? The voltage will, current will pass from positive to negative here. Understood my point? Whenever we are getting this grounded, the internal thing, at this particular point, this stage is also known as quasi bidirectional state. That means we don't consist of 0 here, we don't consist of 1 here. That means almost we will consist of 1, but we don't consist of 5 volts. So VCC is 5 volts, right? We don't get actual 5 volts here. You will get most of the time 3 volts or 3.5 volts, and sometimes you will get 0 here. That means it is in the floating state because we have grounded this entire pull-up resistor to your ground. Okay, now whenever it is grounded, that means it is nothing but your quasi bidirectional state. So that is your quasi bidirectional state. So whenever quasi bidirectional state in this particular point, which will makes your which we can able to read the data from your pin. So whenever if you send 0, you will get 0, and whenever you will send 1, you will get 1 here, and there is a read pin. So whenever if you want to make the signal to pass through this buffer, you need to make this signal to 1, so that we can able to enable the tri-state buffer. We can able to send the signal. We can able to store that inside your latch, so that I can able to read this latch with the help of this read latch signal. Understood? So this is your input operation. And coming to the output operation. In output operation, I want to send the 0, right? And whenever I'm sending 0, I'm applying the clock signal. I will get 0 here. I'm get 1 here. So whenever I'm getting 1, the transistor is on. That means I have grounded this one. So whenever this is grounded, we can send value 0 here, right? This is the 0. That means I am writing the 0 here. I am sending the value 0 here. This is the output operation of your port 1. And coming to the 1. So whenever this is 1, okay, just like your input, okay, we will get 1 here. So you will get 0, and which will makes your transistor off. That means I am not grounded this one. Okay, so when I am not grounded this one, the value, whatever the value present here, it will go to your output port. That means you will get, actually it has to be 1. I have written 0 there, it's my mistake. It has to be 1 here. Okay, that is your port 1 output operation. And coming to the port 2 structure, so this is your port 2 structure. Again you have got another AND gate and address. Here there is no data because port 2 can act as only higher order address bus. That's why there is no data here, and the rest of the remaining port structure is similar. Okay, but here we got an extra NOT gate. Earlier it was here and for the port 0, and we got the port 2 here NOT gate. Now you want to make this port 2 as a input port. So how to make it as an input port? We will write 1 there. Okay, you will write 1, apply the right signal, right to latch signal, you will get 1 here, and you don't need to worry about the Q bar because we are not using this Q bar here. Okay, whenever you are getting 1, the same one will be able to send to the signal, right? Because of the control is 0. Whenever the control is 0, the switch is always connected to this particular Q bar. Q. Okay, whenever I'm sending 1, I will get 0 here because we are connecting the NOT gate, right? Whenever you are getting the connecting the NOT gate, whatever the value you will get here, that will be inverted and you will get 0. Whenever if you are getting 0 to your transistor, the transistor gets off. Transistor get off means the VCC can able to we are having a VCC which is having pull-up resistor, which will makes as a quasi bidirectional state. Again, in a quasi bidirectional state, whatever the value will send from the input pin, I can able to read from that particular pin, right? So when I am sending 0 or 1, I can able to read that particular pin with the help of this read pin. Okay, read pin buffer. So in order to pass the signal to this buffer, I will enable this pin with the help of this one because it's a tri-state buffer. You want to enable or disable. Whenever it is enabled, then only it can able to allow the signal pass through it. Okay, and with this, it is the signal is given to the D. Again, you can able to store this information. Either 1 or 0 will be stored inside your latch, and that latch information can be read with the help of read latch signal. Okay, so this is our input operation. Now coming to the output operation, whenever I am sending 1 or 0 to your port 2, so first of all I will send 0. So when I am sending 0 to this D latch, I need to write to latch signal because it is a clock signal. Whenever you are applying clock signal, then only you will get the input signal given to the output. So D input is given to the output, that is your Q. So Q will get 0, and control is 0, right? Because I am not making it as a address bus. Only I am using output operation. Okay, so that control is 0. That means control is 0 means the switch is always connected to Q, and this the Q consists of 0. The same 0 value will given to the NOT gate, and you will get 1 here. Whatever the value I'm getting 1 here to the transistor is in on state because 1. So whenever the transistor is on state and the VCC, I can able to ground that one with the help of this transistor because transistor is on. The VCC, whatever the VCC I'm getting here, that will be grounded. That means technically I'm not having any value. That means I can able to send the 0 from your output particular pin. Okay, that is your 0. And coming to the right to 1. So when I want to send 1, what I need to do? So I will apply the latch and I will send 1 so that I can able to get the control signal 0. Control signal always 0 because I'm not making it as address bus. And when I'm getting 1, the inverted output is given to the transistor, and the transistor gets 0. So 0 means off. Okay, so whenever this is off, the VCC will directly go to your output. That means VCC means 5 volts. 5 volts means 1. That means I am sending 1 to the output port. This is your port 2 output operation. Okay, and alternate function. So I'm sure you know the alternate function, right? So because the port 2 can also access higher order address bus. So if I want to make the higher order address bus, what is the control signal? 1. Whenever if I make control signal 1, the switch earlier it is connected to Q, that will be switched to connected to your address bus. Okay, now you want to generate only one control signal. Why? Because I am only using address, not the data. That's why I am using 1. When I am getting 1 here, I will get 0. Okay, because of the NOT gate. The 0 means transistor is off state. Okay, whenever this transistor is off, the VCC will directly go to your output pin. That means you will get 1 here. That means I have generated the control signal. Okay, so this is your alternate function. And of your port 2. Coming to the port 3 structure. So port 3 structure is similar to other ports, but there is only connected here is a NAND gate. Okay, the remaining input and output operation is just like similar, and I think no need to explain about those operations. Okay, which means this is the end of your ports. And the alternate functions of your port 3 you just now we have seen, because port 3 has 8 pins. Each 8 pins are divided into 4 categories. That is your serial port, interrupts, timers, and control signals. So these 2 pins are used for TXD and RxD for the serial port to send the information bit by bit, and these 2 are nothing but your interrupts, external interrupts, INT0 and INT1. And these 2 are timer inputs, where we can able to give the input to the timer 0 and timer 1. These are the 2 control signals to access the data from the external RAM. I'm sure you know that there is external RAM you can connect. With the help of external RAM, I can able to get the more information. So in order to read or write the information to the external RAM, I need to generate 2 control signals, that is your write bar and read bar. So the port 3.6 and port 3.7 is dedicatedly used for read bar and write bar. Okay, so that is the end of this class. So if you are having any doubts, you can ask me by unmuting yourself.